Hi guys, today we are going to learn how to solve the support reactions of continuous beam loaded with somewhat like complicated loads. When we say complicated or multiple loadings, these are combinations of triangular load here, rectangular load here, and one external moment, another concentrated load which is inclined at 60 degrees. And when we say continuous beams, these are beams described as having multiple number of support reactions. In this case, we have roller at A, internal hinge at B, and fixed support at C. Okay, this is classified as statically determinate beam. Although we have 4 reactions to be solved, we have 1 at roller at A, and then 3 at the fixed support at C. Why 3 at C? Because we have 1 vertical reaction, 1 horizontal reaction, and 1 moment at C. So all in all, we have 4 unknowns, but we can solve it by using the 3 equilibrium equation only, considering the internal hinge at B. So meaning, here, at the internal hinge, we can cut the beam into 2, considering left portion and right portion, whichever is simpler. So in this case, we are going to isolate part AB here to get the reaction at A. So to do that, we have to redraw the beam, cutting it to 2 portions. This is B here, and then we have the portion of 3 kilonewton per meter at 1.5, and we have the triangular load here. So considering the equilibrium of this portion AB, we can solve for the vertical reaction at A, taking summation of moment at B equals to 0. Okay, so we have summation of moment at B equals 0. We have 3 multiplied by 1.5 multiplied by half of 1.5, that's 0.75. Okay. Then plus, we have the resultant of the triangular load here, that is 8 multiplied by 5, that is 40 divided by 2, it's 20. And this distance, we need this distance. In order to solve for that, we have here the 1/3 of 5. 1/3 of 5 is 1.67. So meaning this is, since this is 2, then this is 1.67, we have 0.33 here. So all in all, this 20 is 1.5 plus 3 here, meter, 4.83 meters. So 20 multiplied by 4.83. That is RA all over 4.5. Okay. So that will give you 3 times 1.5 times 0.75 plus 20 times 4.83 divided by 4.5. So we have 22.22 kilonewton. RA is 22.22 kilonewton. Okay, so we now have the value of RA here. What we have to do next is to solve for the vertical reaction at C. And this is RC. Okay? So here, you have 2 options. One option here is to cut the beam. Again, consider the right portion here. So you cut this beam, consider the right portion, you can actually have RC here, two unknowns, RC and the external moment at C. So we cannot use this option. Okay, why? Because we have two unknowns. One is RC and then the moment at C. Okay. So what we do now first is we are going to consider the whole beam and then taking summation of forces vertical, considering the given external loads. Summation of forces vertical equals 0. So since we now have RA here, then these are the external load, then we can solve for RC. Okay, let's start. So our next step is to solve for RC using summation of forces y equals 0. So here we have 8 times 540 divided by 20 plus 3 times 4 is 12 plus 24 sine 60. Then we have RA here 22.22 minus 22.22, that is equivalent to RC. Well, 3 plus 12 plus 24 sine 60 minus 22.22. That will give you 30.56. So RC now is 30.56. Okay, kilonewton. So we now have value for RA and then RC. Next we go to solve for the moment at C. Okay, so our option is we can use again the whole structure, taking summation of moment at A, then we can solve for MC. The not good thing there is we are going to use all the external loads. So we will be having a very long equation. Our second option is take the equilibrium of the member BC, consider the right side. Okay, let's do that. So consider BC. Now then draw the beam showing only the portion here. So this is 2.5. We have internal hinge at B here. It's 35. So we have these distances. This is 1, this is 2, this is 3. Okay. So taking summation of moment at B is equal to 0. Summation of moment at B equals 0. We take this one. 3 times 2.5. 3 times 2.5 multiplied by 2.5 over 2. 1.25 plus 35, okay, plus 24 sine 60, that is 2.5 to 3 plus 5.5. Okay, then we have RC here minus RC multiplied by, we have 2.5, 8.5, then plus MC equals to 0. So again, we have 3 multiplied by 2.5 times the moment arm 1.25 plus 35, the external moment here. Do not multiply it with the distance because this is already moment. Plus 24 sine 60, 1 sine 60 because we only consider the vertical component of the inclined load here. Multiplied by 5.5 minus RC here, multiplied by 8.5 plus moment at C is equal to 0. Take note that we only assume the direction of MC here. If the answer is negative, meaning the assumed direction is incorrect, you have to place it in the reverse direction. Okay, so we can now solve for the moment at C using that equation. So RC is 30.56 multiplied by 8.5 less 3 times 2.5 times 1.25 less 35 less 4 moments at C now is equal to 101.07 kilo Newton meter. Okay, so we are through with the solution of continuous being loaded with multiple loading with support of roller, internal hinge, and fixed at one end. What we did is consider portion AB, and using the equilibrium equation we get value of RA, consider this portion. And then second is taking the whole structure, we use summation of forces vertical, we solve for RC. And cutting the beam into two, considering the right side or considering BC, we have this drawing. And then we solve for MC. MC is positive 101.07 kilonewton per meter, meaning our assumption for the direction of MC is correct. Okay guys, I hope this video is helpful in understanding how to solve support reactions or multiple beams or continuous beams with multiple loadings. See you for the next example.